Hello everyone, my name is Samir Kumar Singh. I am PhD scholar in Electrical Department at IIT Roper. Today I am taking the E5 tutorial. Here we will discuss few questions that will help you out to solve the assignment number 5. Okay, question number 5 is on your display, and that is the find the relation between the time resolution and the bandwidth. Please read this question and try to answer this question. Question number 1 is the find the relation between the time resolution and the bandwidth. Option is it is directly proportional to the bandwidth, inversely proportional to the bandwidth, 2 times our bandwidth, and half of the bandwidth. If anyone had doubt regarding this question, can ask. Yes, simply we have to tell what the relation between time resolution or time resolvability and the bandwidth. So question number 1 is on your display. Just simply answer this question. It's a theoretical question. Okay, so the right answer is the B part. It is the inversely proportional to the bandwidth. So mainly the formula is that between the time resolution and the bandwidth is that time resolution is equal to the 1 times of the bandwidth. So B part is the right answer. Now next question is that the 3 channel impulse response are plotted below. Which of the channel impulse response corresponds to channel with the smallest bandwidth? There are 3 response are given. One is the blue, second is the red, third is the black. So you have to tell which of the channel impulse response correspond to the channels with the smallest bandwidth. You have to tell which channel have a smallest bandwidth. I am giving you a hint. Using the concept of first question, you can apply there. You can get which have the smallest bandwidth. So please try to answer this question. You can. First one is the blue curve, red curve, and the black curve. You just have to tell which channel have the smallest bandwidth. Okay. As I told you, time resolution is the inversely proportional to the bandwidth. So here you check the smoothness of the curve, smoothness in the curve. Which curve have the more smoothness have a smallest bandwidth. If you see the black curve and compare to the red and blue, so black is the more smooth, so it's have the smallest bandwidth. So C is the right answer. If you compare the blue and red, then red is the right. Then red have the smallest bandwidth. But in all three, black is the right answer. Black is the right. So C part is our right answer. So this is explanation of this question. The time resolution is inversely proportional to the channel bandwidth. This is already we see in the question number 1. So less resolution in the time means that the impulse response looks smooth. As C looks smooth, it should have less bandwidth compared to the other two. C is the right answer. Question number 3 is the theoretical question. Question is that Russian channel mainly represent LOS component, NLOS component, both or none of them. As you know, we have various channels, relay, Russian, Nagagami. So you have to tell which the Russian channel mainly represent which type of component. So guys, read it and comment your answer. You can comment, you can speak. It have LOS, NLOS, both or none of them. I'm waiting a response. Try to answer this question. Russian channel mainly represent. Okay. So right answer is the LOS component. Basically, Russian channel consists the LOS component, and LOS is known as the line of sight component. The dominant part in the Russian channel is the LOS component. Similarly, NLOS known as the non-line of sight, and our relay channel consists the NLS component more. And in the relay channel, NLS is the dominant. While for the representing the LOS component, we are using the Russian channel. Okay, so answer is the A part. Okay, sorry, it's mistakenly it's type B, but answer correct is the right. I will edit in the PDF. Okay, so it will be A part. Russian channel mainly consists LOS component. Okay. Question number 4 is on your screen and it's asking channel tracking become unreliable in the case of. We have to tell in which case our channel tracking become unreliable. There are the 4 options given. Please read it and try to answer this question. Question is the channel tracking become unreliable in the case of. Option is the node fading with low Doppler, fading with low Doppler. C is the no fading with high Doppler. Fourth is the fading with high Doppler. In 2 cases, fading is considered, and B and D, sorry, in A part and C part, fading is not considered, but in B and D, fading is considered. We just have to tell channel tracking become unreliable in the case of. If anybody got the answer for the channel tracking become unreliable in the case of. So answer is the right answer is the D part. Channel tracking become unreliable in the case of fading with high Doppler. Okay. So D part is the right answer. Next question is related to interleaver. Question is that in interleaver, data in and out is happening in this form. Data in means transmitting end, data out is the receiving end. How we transmit our data, how we in our data, or and how we are doing out. We have 4 options. Interleaver, data in and out is happening in which form? So answer of this question is that data in is vertically and out is horizontally. Suppose we are entering your symbol 1 2 3 4 5 6. So data in form of 1 2 3 4 5 and then 6. In out, we in the case of in, we read in such in vertically, and in the out we read in horizontally. So D part is the right answer. Data in vertically and out horizontally. Next question, the numerical question. Question is that consider a system that use coherent QPSK modulation and detection scheme with 10 microsecond symbol period for the communication. Symbol period is given at 10 microsecond. Channel has a coherence time of 4 millisecond. Coherence time is given at 4 millisecond. And condition is given if 100 symbols are being used for the transmitting training sequence for the channel estimation, to find a data rate without considering the training overhead. We have to find the data rate. Then question given is the symbol period, coherence time, 100 symbols for the channel estimation. We have to calculate a find a data rate. Guys, please try. If anyone got the answer, can comment. Speak. I'm giving you a hint, guys. Firstly, we have the symbol period and the coherence time. By using that, you can calculate the number of symbols and subtract the number of symbols, subtract the channel 100 symbols because it is using for the channel estimation. You can consider consider it as a as overhead. So firstly, calculate the number of symbols by using the symbol period and the coherence time. Try it. Okay. So firstly, I tell you that firstly we will calculate the total number of symbols. Okay. So total number of symbols transmitted in the coherence interval is equal is the ratio of the coherence time and symbol period. Coherence time is given as a 4 millisecond and symbol period is given 10 microseconds. From there we will get our number of symbols and it is the 400. Okay. And condition is given is that 100 symbols are being used for the transmitting training sequence for the channel estimation. So we will subtract it. Total sum numbers of symbol is the 400 as 100 symbols are allotted for the sending training sequence for the channel estimation. So we'll subtract the 100 with the 400 and we will get the 300 symbols. So only 300 symbols are only 300 symbols can be data. So we have to calculate data rates. So it's data rate without considering the training. However, it is a 300 symbols in the 4 milliseconds. Uh, it will come out of 475k symbols per second. In a kbps, it will come out of 150 kbps. So guys, if you have any doubt, you can ask. So right answer is the A part, 150 kbps. Next question is that for the QPSK, assuming EV by N0 is a 8 dB, evaluate VAR in AWGN channel using the exact expressions. Here EV by N0 is given. We have to calculate the VAR in AWGN channel. Channel is given as AWGN. Given is that EV by N0. Our SNR is given 8 dB. So just firstly calculate the EV by N0 in a linear scale. It is given in dB. And just put the formula of the VAR in AWGN channel. You can get your answer. Please try. If anybody got the answer, can comment. I'm giving you 30 seconds more. Please try it. After that, we will see the solution of this question. Okay. So given is that EB by not 8 dB. From there, you can calculate in a linear scale. So it will come 6.309. And the formula of the BAR for the QPSK, it's Q under root 2 EB by N0. We will add all these things in there. And from there we can get our BAR by using the Q calculator. It will come 1.91 into 10 into 10 is to minus 4. So right answer is the B part. Next question is that question number 8 is that what is the most appropriate model for the cellular transmission where a dominant line of sight pulse plus many beak reflections are present? only. So guys, we have four options, and it's given that here the dominant part is the line of sight plus many weak reflections are present. So please comment the answer of these questions. Which is the right? What is the most appropriate multipath model for the cellular transmission where a dominant line of sight plus many weak reflection? This model have a line of sight plus many weak reflections. If anybody got the answer, can comment. Okay, now we'll see the explanation of this question. As I let you know that relief fading consists of mostly the anomalous component. Here they are asking about the dominant line of sight plus many weak reflections. So Russian is the right. Similarly, Nakagami also followed this nature. So B and C the correct option. The option D is the right. The answer is the D part. Next question is given that here we have a plot, and question is that consider the graph given below. What is the fading margin for the Rice distribution with KR? KR is the parameter of the Rice distribution, 0.3 dB. Okay, KR is there we have three value of KR. First one is 0.3 dB, 3 dB, and 20 dB. In a curve for the all case we plotted that it is the for the 0.3 dB, and that is the 3, that is the 3, and that is the minus 20 dB. Okay, the question is what we have to calculate here. What is the fading margin for a Rice distribution with KR is equal to 0.3 dB such that the outlier probability is less than 5%? So guys, please see this plot and try to answer this question. You have to tell what is the fading margin for KR. 0.3 dB. So just look at the plot. Okay, yeah, it is asking about KR is the 0.3 dB. So for the plot for the 0.3 dB is that this line. Okay, so we have to tell the fading margin such that the outer probability is less than 5%. So for the curve, for this curve, we are achieving the P outage at that point. Okay, P outage is given 5% for at that point. So answer is the 11.5 dB. Okay, fading margin is the 11.5 dB. So right answer is the D part. One second, guys. My battery is dying. Okay. So answer is the D part. Similarly, repeat the above question for the KR is equal to 20 dB. And this time we have to consider this curve. This curve is given for the 20 dB. And outer probability is also for the 5%. We have to do fitting margin for the that curve. Please let me know which is the right option. Okay, let's look at the curve. Okay, this curve represents the 20 dB and it's got the P out as the 5% at that point. Okay, so answer is the 1.1 dB. 1.1 dB. Okay. If anybody have doubt, can ask. Okay. Next, the statement type question. Question is that this of the following can result in catastrophic error propagation. Which of the following can result in catastrophic error propagation? Option: the current modulation, current detection, differential modulation and differential detection, differential detection and current modulation and differential detection. Please read the question and try to answer. Question is, again I am repeating this question. Question is that which of the following can result in the catastrophic error propagation? So explanation of this question is given that here. Answer the T part and explanation is given there. Current detection and differential modulation leads to catastrophic error propagation. That is, if there an error in detection if of 1 bit because of the considering differences while demodulation, the error will propagate to the future bits catastrophically. So D part is the right answer. Current modulation and the differential detection is create catastrophic error. Question number 12 is numerical question. Question is that calculate the BER for the current PPFSK in relay fading if the average SNR is 8 dB. Here SNR is given and here SNR is given and we are using the current BFSK in relay fading. Calculate the BER. Let's try it. Try to solve this question in your notebook. Again, I am repeating this question. Question is that calculate the BER of current PFSK in relay fading if the average SNR is 8 dB. Okay. Average SNR is given 8 dB. You can convert in the linear scale. It will come 6.3A1. We have to calculate the BER of the current PFSK for the relay fading. Formula is given 1 by 2 1 minus under root gamma upon 2 plus gamma. Just put the value of this there. You can try this expression by using the calculator. So here we are getting the BER is equal to 0.064. So answer is the C part, 0.064. If anybody have doubt, please let me know. Simply just calculate 8 dB in the linear scale, it will come 6.31 and put in that formula. The expression was already discussed in the lectures. Okay. Next question also again related to interleaver. Question is that SM cross N interleaver takes Mn bit as an input. Okay. Insert from the column wise into the M cross N matrix and output bit are produced by the reading the elements of this matrix row wise. Consider a 8 cross 10 interleaver at a transmitter. Which of the following blocks can de-interleaver a transmitted bit at the receiver? This question is already related to the interleaver. Here we have to let you know Which of the following blocks can de-interleave the transmitted bit at the receiver? There we are talking about an de-interleaver. Interleaver you are using at the transmitter end, and, and the size of this 8 cross 10. Okay, so try to answer this question. Here you have to tell which of the following blocks can de-interleave the transmitted bit at a receiver. Same type of questions already discussed in the so using that concept you can answer this question. Okay, anybody got the answer can comment. M cross and interleaver takes mn bit as input, insert them column wise into an M cross n matrix. The output bits are produced by reading the elements of the matrix row wise. Consider a 8 cross 10 interleaver at a transmitter. Which of the following blocks can de-interleave the transmitted bit at the receiver? The answer will be a B part. Transmitter is the size of 8 cross 10 and the receiver in at the time of the T interleaver process, that is the reverse process of the interleaving. So it will become and the size of 10 cross at interleaving. So our option is the B part. The explanation of this question: if the interleaver is of size of I cross Z, the J cross I interleaver can act as a T interleaver. That's just the opposite side. Next question is given there. Question is that consider a scenario where the receiver is between a transmitter and a reflecting wall at moving towards the reflecting wall. Okay. As the receiver is closer to the wall, which of the signal corresponds to the resultant wave received by the receiver? Again, I'm repeating this question. Question is that consider a scenario where the receiver is between the transmitter and a reflecting wall. Okay, and the moving towards the reflecting wall. The receiver is going towards the reflecting wall. As the receiver wall is at the receiver is closer to the wall, which of the signal corresponds to the resultant wave received by the receiver? There are three types of output is given. X-axis represents the time, the y-axis represents the amplitude. You have to let you know which option is the correct. Just comment which of the signal corresponds to the resultant wave received by the receiver. So guys, please comment your answer. As the receiver is closer to the wall, which of the signal corresponds to the resulting wave received by the receiver? So the right answer of this question is the C part. Blue is the okay. Yeah. So answer is the C part. Okay, blue part, that one. Next question. Next question is that consider if sorry this was mistakenly typed mistakenly. Question is that consider a flat spreading system. R is equal to Z into S plus N. S is the symbols, N is the noise. As explained in the lecture, Z is the It's consists of mean 0 variance 1. If the D fit uh, occurred when the sonar flow fall below 0 dB, that is the z mod z square gamma less than 1. Calculate the approximate probability of the D fit at a high sonar, high gamma. Question again, I am repeating this question. Consider a flat fitting system. R is equal to z into s plus n as explained in the lecture. Consider the mean 0 and variance 1. Okay. If D fit occur when a sonar fall below 0 dB, a system goes in a deep flow where a sonar goes below the 0 dB, that is z square gamma less than 1. Okay. Gamma is a sonar. Calculate the approximate probability of deep fit at a high sonar. Here we have to calculate the probability of deep fit for the high gamma. This, this is the question number 15. Okay, we have to calculate the approximate probability of deep fade at a high sonar. This is the scenario. Consider a flat fading system. R the received signal, as the transmitted symbol, and is the noise. We have to calculate. If anybody got the answer, can comment. Okay. Okay. Now we'll see the explanation of this question. We have calculated the approximate probability of deep fade at high sonar. Okay. Probability of deep fade for the high sonar and given is that um, sonar fall below 0 dB. That is the z square gamma is less than 1. So we have to calculate from there. So the value of mod z square is 1 upon gamma, and we know that z square follow the exponential distribution because that is a relay to pass have its z square will become exponential distribution. From there we can calculate probability of error probability. So let's go from the 0 to 1 upon gamma, and distribution is the e power minus x into dx. So by the simply applying the integration, we can calculate that it will come 1 minus e upon minus 1 gamma. We can expand that. Okay, so it will be 1 minus 1 gamma, but that is the high order terms, and gamma is the very high, that will be very low. So it's approximately it will come 1 upon gamma. Okay, if anybody have doubt can ask. So sorry, so answer is the A part. Okay, thank you.